Hello everyone. Today we're going to talk about sprayer calibration. And the first thing I'd like to do is give an overview of the equipment that we're going to be using. And so this right here is a CO2 tank. This is used to adjust pressures for your application. Some applications are going to be better at 30 psi, some at 50 psi. And that attaches directly to this liquid canister. So this is where we would typically put the herbicide. And then it immediately attaches into the whip. And the whip attaches directly to a ball joint valve, which is currently in the closed position. And that allows for herbicide or whatever liquid that you're spraying with to go through these nozzles. And so this happens to be a selector where we can choose between 5 different nozzles available to us. And next we have a T-jet pattern check. And so this is basically as these guards catch the water will then allow for the float device to rise, showing us the level of liquid that's present or that was caught from each nozzle. And so next I'm showing you guys how to remove these nozzles. For anyone who hasn't worked with sprayer equipment previously, there's just a twist off for the caps. And then after I remove all of the nozzles that we're going to be showing and working with you guys on today, then we can go ahead and talk about a little more about these nozzles. So this right here is the XR8002. Next, we have the TTI 11003. And then lastly, we're going to be working with the AIXR 11004. And just to show you how these pieces are assembled, basically you can push them out. It has a little rubber O-ring and then just the nozzle head. This right here is going to be an application at 19 inches. And so in one of the problems that we're going to work through, this is going to be the proper height for our application for the XR8002s. And so we see it spraying out right now. We have our T-jet pattern check just underneath it. So we're going to let it spray for a little bit, and then we're going to see how even our application is. And so here what we see is an even line across for our T-jet pattern check. And so that's what we're looking for. This is supposed to give us an image of what application would look like at this height in a field. Next, we have an application at 8 inches. And so this is going to be an application that's too low. And so we want to show you that when an application is too low, that has adverse effects on the entire application. And so we're going to let this run for just a few seconds, and we'll see what happens if you were to make an application that was too low. So we begin to see these high points and low points within the fields. Next, we have an uneven application. So if your boom equipment is not even across, you would also begin to see almost like waves within your application pattern, where some areas would receive more herbicide than the others. And lastly, we also have an application at 45 inches. So this is way above where we should be applying. And what we see on the lower part of the screen is that with this nozzle producing fine particles or fine droplet sizes, we have more of a chance of our chemical moving off target. So these nozzles have the highest potential for drift. And so next I wanted to show you guys about nozzle droplet size. So each one of these nozzles is rated for a different droplet size at different PSI. And so all of these currently are set for 30 PSI. So the first one we have for you is the TTI 11003. And we can see that this is producing an ultra coarse droplet. And then next we have an AIXR 11004. And so this is producing a coarse droplet. And then next we have an XR8002. And this is producing a fine droplet. So meaning a small droplet. And this is the nozzle that has the most potential for drift. So this is right here a video of another side-by-side comparison. So we see the size of the particles. We take a zoom in to look at them a little bit closer, and then we can see a side-by-side of the TTI 11003 and the AIXR 11004. After that, we can go ahead and make a comparison for the AIXR 11004 and for the XR 8002. We can see the difference between a coarse and a fine droplet. And again, the difference in the droplet size for the XR 8002s gives it more of an opportunity to be susceptible to drift.
Which you can kind of see it.
Oh yeah, okay. And so what we see right here next is the catch test. So this is an exercise we're going to run with you guys, and we'll run through the math in lab. But basically we are setting the PSI for the XR8002s at 30 PSI, and then we are catching the liquid that comes out in 15 seconds. After this, we adjust the pressure to 50 PSI, which is the proper PSI. And then we complete another catch test for 15 seconds. In the first catch test, we found that the volume came out to 167. And in the second catch test, at the proper PSI, there was a volume of 190 milliliters. 2, 1.
About actually 190 and
190 right now?
Yep.
And so one of the last things we want to show you today is how to set up a spray boom. And so we have our liquid canister, and we have our whip attached directly to that. And then the whip attaches directly to the boom. Just to note, all equipment has been cleaned previously, and we weren't spraying with any herbicide. This was just liquid and food coloring. Once we have our CO2 tank attached, one thing we need to do is charge the boom. And so this is removing any air within the boom and making sure that we have herbicide at the nozzle tips for the application. And then we see Madison here giving us a demonstration of what it looks like to spray a field. Okay. And this concludes the demonstration for today's lab, nozzle calibrations. Thank you guys.